on one hand, we have management endpoint, where we create a fleet, set up a fleet, set up a tier, and start creating databases. And Fleet Manager control plane does all these fancy things under the hood for us, like load balancing, scaling, config management, etc. And we have pretty much a stable connection point for our application workload. So connecting to a database in the fleet is done by connecting through something we call stable connection endpoint, which is a fleet level connection, which survives any database movement throughout the life cycle of the database. So when Fleet Manager moves something around, your application doesn't have to worry about it. The connection string remains immutable throughout the life cycle. And of course, Fleet Manager is managing these databases under the hood for us, moving them around, etc. So we were looking at what we need to do to provision tenants with Elastic Pools today, and we'll see what this looks like when provisioning tenants with Fleet Manager. So we're going to have an app, we have a catalog, and as a one-off initial step, we created our fleet, our tiers, and created one fleet space. So when our new tenant comes, the application just asks Fleet Manager, give me a database for this new tenant that's coming in. And as more tenants register, application just asks for the new databases, but the Fleet Manager automatically creates more and more Elastic Pools and creates more and more databases as needed based on what the application asked. And it automatically scales the pools up and down, moves databases between pools. Pretty much everything we needed to implement before, this is done automatically for us with Database Fleet Manager. So let's double click into one tier. Like we're running our fleet successfully, our application successfully for some time now. And let's see what happens in real time. So the first thing Fleet Manager helps us, we mentioned this a few times, this is database placement. So when I'm creating a new database, Fleet Manager looks at all the existing provisioned resources, provisioned Elastic Pools. So here, each of these boxes is a general purpose Elastic Pool with 6 vCores, and we have a setting, we don't have more than 5 databases per pool for this illustration. And when a new tenant comes, Fleet Manager looks not only at the number of databases in each pool, but also looks at the recent resource utilization. So if a pool is over some certain CPU threshold, for example, it's not a place where we want to put this new database in at this moment in time. So one database comes, we can put it in this one existing pool. For a second new database, we need to provision the new one. Tier rebalancing is also something that we get with Fleet Manager. So we're running our application. We see that this database in this pool is getting hot, as represented by the red color here on this diagram. So what Fleet Manager will do, it will try to rescue these good citizens from this noisy neighbor by moving these databases from the pool to different Elastic Pools, thus preventing performance issues in this database. So it proactively tries to provide good performance for all our tenants and prevent this noisy neighbor, mitigate as much as possible the effects of the noisy neighbor in an Elastic Pool. It can also do short-term mitigation by auto-scaling an individual pool. So let's say the pool gets hot. It can temporarily upsize the pool, accommodate this peak. And then when things get settled down, things get hot, SQL bits passed, so there's no more traffic or something like that, the pool scales back down to its original size. And of course, this is all good to optimize performance, but what about cost? The number of pools will explode, right? Well, once things settle down, Fleet Manager will proactively try to reduce the number of Elastic Pools and save cost as well. So these two competing algorithms, one trying to optimize performance, the other trying to optimize cost, are always fighting each other. And once things get a bit more settled down, Fleet Manager will move these databases back to a pool that has room and is not hot, and will delete this, reduce over provisioning pretty much for us. So this is pretty much this auto management, and we'll now cover a bit on the user experience for us that need to use this Fleet Manager. So first, let's say I'm a fleet admin. I want to create and maintain. So this is very much a DB admin, but at the fleet level. So we're not treating databases as pets anymore. We treat them as cattle, especially the less important customers. Not the customers, but maybe that's not a good comparison. So the fleet admin creates and maintains fleets. configures pretty much security, compliance, networking, authentication, everything at a fleet level to make sure that it propagates to the fleet to stay like compliant or whatever the good people from the security teams and other require from us. We create these tier definitions where we determine the end user experience for our end customers, the airlines, and ultimately define the cost that each database we provision will end up costing us. And this is usually done through manual or scripted operations, so usually Porter or PowerShell CLI, but not restricting. Then we have a platform developer who's in charge of provisioning, managing databases. So we have these provisioning management APIs, which provision databases in appropriate tiers based on whatever our need is. And of course, doing some database level operations, such as restoring DBs on customers' demand, for example, or moving databases between tiers as customers become more or less important or grow more or less. And of course, monitoring per tenant level or fleet overall level. And we have an application developer who's pretty much running the workload. So he just needs to connect to the databases through this stable connection endpoint, run workloads, and it's using existing Azure SQL drivers, so there's no app modification needed. Again, we're not reinventing the wheel. We're not doing anything new. It's all creating new. It's all running on top of existing stuff. So no change there. So let's walk through the experience of creating a database fleet. So this is a preview of what this feature will look like. So we're now in Azure Portal, and we're creating a database fleet. And we need to, of course, specify a subscription or resource group where we want to create this resource, that specify a fleet name, and we can set some. We can set some authentication settings. We can set some networking settings at the fleet level. But most importantly, we want to set our tiers, right? We can create, if you are someone who likes to have more control, to have more knobs, to fine tune, the person that tweaks the antenna to find a better signal, we have an ability to really define the size of these nodes that the fleet manager will provision, which are elastic pools in this example that we were using before. So first we define for this tier, do we want to use elastic pools or not? So if this is a tier for our premium customers, we don't want to use we don't want to enable resource sharing within this tier. So for our Heathrows of the world, or maybe Farnboroughs tomorrow, who knows? We don't want resource sharing. We want them to have standalone databases and have the best service possible. And then if we are using elastic pools in this example, we can choose service tier. So we can choose any service tier that's available in Azure SQL DB. So for our less important for our general audience, we want a general purpose, which is more than enough for Farnborough and other. So they will have to compete for resources with Reading and other. I don't know what's the enemy city of Farnborough. And we can choose different compute tiers, and we specify storage compute settings per each elastic pool within this tier. And to control the cost and performance, pretty much what will define the end user experience is the per database configuration in terms of capacity. So we say each database, even though the elastic pool is 8 vCores, each database is restricted to 4 vCores in this tier. And to prevent any issues, we limit the maximum database count per pool to 50. So all the algorithms that Fleet Manager provides, like database placement or load balancing or defragmentation, they all take this into account when making the decisions throughout the fleet life cycle. But of course, if you're just getting started or you're not sure, like I'm just building my application, how do I know how many cores do I need or how many databases can I place in a pool? We of course offer some preset tiers. So we've been analyzing some internal data, our applications that we build in Microsoft, and we ended up with a few tiers that can be like a good way to get started. So we have creatively named here bronze, silver, and gold tier. I have to, of course, make a disclaimer. This is a mock-up. These numbers are made up, so don't take this as a set in stone thing. But the illustration I'm trying to make here is that here we have like 3 different tiers of quality of service. Like on the one end of the spectrum, we have this bronze tier where we have general purpose 2 vCore pools with 100 databases per pool. So this is like we really aim for cost optimization, and we're okay with sometimes having a bit of a throttling or something for our databases. And on the other end of the spectrum, we have gold tier. Maybe we could have a platinum tier without resource sharing. But yeah, as I mentioned, this is just an illustration, not what this will look like in the future. But on the other end of the spectrum, we have more capacity, we provide more storage, and we have a lower number of databases per elastic pool. So these like preset configurations is something you would get if you just want to get started and play with pretty much start running your fleet, monitor how it's going, and then of course adjust as you go, tweak, fine-tune these knobs, and find your optimal price and performance ratio. And of course, it would be great if the platform would also do that for you, right? So based on your workload, fine-tune these parameters as well. So that's something that may be coming as well. Why not? So let's double-click into our application. So this is where we need to create a new tenant and connect to a database. So as you can see, this is quite literally a one-liner. That was the whole point of this exercise. So from an application standpoint, creating a new tenant is literally a one-liner. You specify which tier this new tenant should fall into, which fleet, and you get a connection string pretty much in a response, and you can just connect to this new tenant. So there's no logic to maintain. There's no working around any limits that may change one way or another in the underlying resources that you manage. Everything will be managed by the fleet manager, and you don't have to change your logic, whether your business changes or whether the Azure offerings evolve through time. So you just change your tiers, you just change your fleets at the central configuration management place in the fleet, in the tier, and it all automatically happens for you behind the scenes. So to pretty much wrap it up, Azure SQL Database, Azure SQL Managed Instance, these are successful battle-tested offerings for hosting SaaS solutions. So many SaaS builders are using these today to host their database per tenant architecture-powered applications. So it's already running for some time, and it's running thanks to these existing building blocks that we saw with elastic pools in Azure SQL Database, or with managed instances and instance pools in Azure SQL MI. And of course, there are these out-of-the-box things like database mobility, business continuity, things you get in Azure pretty much as a given, right? So these building blocks help you build these applications today. And we are introducing another simplification and another boost to this, which is called Azure Database Fleet Manager. So as I mentioned, this is a new capability, which is currently in private preview. So if you are interested to test this out, we'll have a link in the end to pretty much give you a chance to apply. It allows you to create different database tiers and enforce configuration policies, and it helps you maximize resource utilization through these auto-management operations that are running behind the scenes, so cost optimization and performance optimization at the same time through some autonomous auto-management operations, such as load balancing and smart database placement. So with this powerful combination, we can focus on our application and building our ticketing system, and we can confidently offload all the complexities of building this application type to Azure Database Platform for managing our database fleets. And of course, the most important thing is you can scan this QR code and rate the session with a good mark. And on the other side, you can apply for the private preview of this Azure Database Fleet Manager thing, and pretty much take it out for a spin. This second QR code will lead you to a blog post where our good friend Silvano Curiani, here present, pretty much provided a brief intro to the feature, and at the end of the blog post, you'll find a nomination form to apply for the private preview. So we're open for, that's it. We're open for any questions you might have. Thank you.
So I have a question because at the moment Azure SQL DB, how it works when you scale the database up and down, it can move you to another node, and that means your cache is trashed. So this movement between the pools, is there any movement in terms of on the node level on the back end, or is it one node allocated with resources that is just a logical move?
Yeah, that's a good question. So it will be for now it will be we're working on not being moving the cache as well.
Mm-hmm.
For load balancing operations, actually, it will persist the cache. That's depending on the type of move itself. Yeah, if it's an SLO change or scale. Yeah. So it.
But in general, you can face both situations.
Yeah. There's a bit more. It's not a yes or no answer. Yeah.
Some online question?
My next question is, would you have the possibility to tune the algorithm? For example, let's say you have that database utilization graph, so maybe you can add percentages or something, or how is it calculated? Would there be like a description or a formula?
Yeah, that's also a good question. So we're currently not disclosing anything there, but of course, as you can imagine, you have a threshold over which you consider a pool or a database caught, and then a certain duration that the utilization needs to be over a certain threshold. There are various dimensions that are monitored, so it's not just CPU. Like this is like the high level that I can provide, and whether or not we are going to provide the fine tuning for end customers or it's going to be done internally, that's something that will be disclosed at a later point in time.
Good. Seems like we're done.
Yeah.
Thank you very much.